on your session, and please turn off your video and also mute yourself when it is not your session. Yeah, I
Okay.
think that's all. I think we can just wait for another and to relax for another 7 minutes until we start. And see you again.
See you then.
Yeah. Hello, everyone. It's nice to see you again here. Hello, my name is Monica Merdekawati. I am the researcher of ASEAN Climate Change and Energy Project, and also the researcher of Sustainable Energy and Renewable Energy and Energy Efficiency Department of ACE. Uh, in this today talk, I will be your moderator for the next 1 hour. Uh, so here we will discuss an academic article entitled Intercomparison of Transboundary Atmospheric Dispersion Calculations, Summary Outputs from the ASEAN NPSR Benchmark Exercise. This study presents the potential dispersion pathway of nuclear radiation if a fictional accident happens in Fangchenggang nuclear power plant that located just around 70 kilometers from the border with Vietnam. I'm quite excited to learn from the experts behind the study, in particular to understand what exactly the risk is. Perhaps what we perceive from the public eye about nuclear is not accurate, and maybe it is safer than we thought. So, without further ado, we will begin by introducing our two speakers here who will jointly present the study. We have Dr. Kampanart and Dr. Kampanart Silva and also Mr. Wasai Vechgama for about 20 minutes to present the study. Then it will be followed with an interactive Q&A session and a few updates of our future events for the rest of the session. In the Q&A session, I'm encouraging all the participants to share your questions through the Q&A feature. If any of you would like to share your opinion directly, please use the raise hand feature to notify the host so we could promote you as the panelist. Hence, you will be able to unmute and open your camera. Again, please do not hesitate to be involved in the discussion. Okay. Now I would like to briefly introducing the first speaker, Dr. Kampanart. Dr. Kampanart is the researcher of the National Energy Technology Center, or NTEC, under the National Science and Development Agency, or NSTDA, while previously he was at Thailand Institute of Nuclear Technology, or TINT. In TINT, his research focused on the assessment of severe accidents in nuclear power plant, in particular the consequence assessment of nuclear power plant accident and also emergency preparedness and response strategy. Now in NSTDA, his focus is on enhancing the energy resilience in renewable energy systems. He is also one of the starting members of the ASEAN networks on nuclear power safety research under the ASEAN Subcommittee on Sustainable Energy Research, and is now an alternative representative from Thailand to the Subcommittee Sustainable Energy Research, and he got the doctoral degree on nuclear engineering and management from University of Tokyo. And our second speaker, Mr. Wasin, is the nuclear engineer at Thailand Institute of Nuclear Technology, or TINT. His research expertise is nuclear power safety research and nuclear risk assessment, severe accident analysis and nuclear consequences, and risk assessment of the nuclear reactors is the focus of the research at TINT. Currently, he is the main contact of the ASEAN network and on nuclear power safety research under the ASEAN Subcommittee on Sustainable Energy Research. Also, he is the project leader of the probabilistic risk assessment of the first nuclear research reactor in Thailand, Thai Research Reactor 1 of TINT. He is graduated from the master degree in nuclear engineering from Chulalongkorn University of Thailand. Hello, Dr. Kampanart and Mr. Wasin. Nice to have you here. So maybe without further ado, I would like to forward the opportunity to you to start the presentation. Thank you.
Okay, thank you very much, Monica, for your very kind and a very nice introduction. So, as introduced by Monica, so this presentation will be given by two of us, Kampanart and Wasin. And then Wasin will be the one who share the screen.
Okay. Please prepare.
Yeah, I have turned off my page.
Okay. So while the screen is being prepared, so I'll just start the talk. So, well, actually, this is about the intercomparison of the transboundary atmospheric dispersion calculations. Well, and as told to you all by Monica, that it's like a summary of outputs of the ASEAN NPSR benchmark exercise. And I believe that, well, most of you here in this room would wonder what this ASEAN NPSR mean. So Wasin will be the one who will talk about this ASEAN NPSR, ASEAN Nuclear Power Safety Research, ASEAN Network on Nuclear Power Safety Research, which is now being looked after by the Thailand Institute of Nuclear Technology and also other representative organization from ASEAN. I think at the moment the lead country is Singapore, and well, Wasin will be the one who talk more about this. And then after that, when you all know about this ASEAN NPSR, then I'll go into the detail of the study on this benchmark exercise, where I will talk about the comparison of the results of the transboundary atmospheric dispersion calculation performed by ASEAN member states. So without further ado, I would like to pass the floor to Wasin.
Okay, hello everyone. Everyone can see my screen, right?
Yes, we can.
Okay, thank you so much. And good morning and good afternoon, everyone here again. My name is Wasin Vechgama, and thank you, Dr. Kampanart, for introducing me, and thank you, Ms. Monica, for the excellent event today. And before we go into the technical term of the paper, I would like to show everyone about the introduction and the background and our motivation of our network. And this is the important starting point of our collaborative project in ASEAN NPSR. And ASEAN NPSR, or ASEAN Network on Nuclear Power Safety Research, was officially established by ASEAN nuclear scientists and a nuclear engineer in ARNECC event in 2017 in Bangkok, Thailand. And the motivation of our network is the concern of nuclear accident consequences from the Fukushima accident in 2011 that affect people and the environment around the world within our ASEAN region. And therefore, the research of nuclear accident consequences have been discussed and conducted together to the intercomparison task among ASEAN member states. As you saw in your right-hand side of the slide, the ASEAN NPSR goal is to strengthen the research and development, human resource development, and regional collaboration of our ASEAN country in the nuclear power safety field in order to also support the formulation of regional strategy of the nuclear severe accident management plan and management guideline in our ASEAN country. And next, this is the next important step of our ASEAN NPSR group. The ASEAN NPSR was contained as the action plan of the ASEAN Subcommittee on Sustainable Energy Research, or ASEAN SCSER, and our network was endorsed by ASEAN Committee on Science, Technology and Innovation, or ASEAN COSTE, in 2017. And in the first year of our network, Thailand was selected as the first ASEAN NPSR leader in order to support the research activity of member states in the nuclear safety research scope. Next slide. Now, ASEAN NPSR includes 9 member states, including Myanmar, Laos, Vietnam, the Philippines, Thailand, Cambodia, Malaysia, Indonesia, and Singapore. And in this year, Singapore is our current lead country. And the next annual meeting will be organized at Singapore next year. And we plan to have another workshop to other ASEAN people too in the next year. Now Thailand is the co-lead country number one, and Philippines is the co-lead country number two. And this co-lead country have the responsibility to continue the research activity and organize the important events after finish all of event at Singapore next year. And next, this is the first successful collaborative project in our ASEAN NPSR. The first collaborative project is the atmospheric dispersion assessment of radioactive nuclei to the benchmark problem. And we have the three main partners, that is Thailand Institute of the Great Technology Thailand, and National University of Singapore, and Vinatom from Vietnam that lead in this part. And there are many researchers from the other institutes that help support us too. And in the outputs of the project, the outputs was published in the Journal of Progress in Nuclear Energy this year, and Dr. Kampanart Silva will talk about the technical term of this paper today. And as for the next step of our ASEAN NPSR, after finishing the first collaborative project of radioactive nuclei atmospheric dispersion assessment, we plan to have another international comparison tag in order to proceed and continue our momentum in network. And those assessment of both internal and external pathways from the accident consequences would be the main focus in order to understand the nuclear consequences that affect two people and the environment more. And in this slide, this is the activity that ASEAN NPSR has since 2017. Now we have the six main activity, and in the next year we plan to have another annual meeting in Singapore and another workshop for normal ASEAN people. And this is my last slide. And before I pass the floor to Dr. Kampanart Silva, I would like to show the official website that we have in order to follow the ASEAN NPSR activities, news, research collaboration information, and to see the contact point of every country that we have. The website name is really easy, just only ASEANNPSR.com. And now I'm finished presenting my presentation, and I would like to move the floor to Dr. Kampanart Silva to talk the technical term of the paper that everyone looking forward to, right? Okay, thank you very much.
Okay, thank you very much, Wasin, for introducing this ASEAN Network on Nuclear Power Safety Research, ASEAN NPSR. So now you know the background of the paper that we spent well, more than 3 years to work on this project to do the calculation of transboundary atmospheric dispersion together. And well, these are the three main countries that contributed quite a lot to this calculation, well, namely Thailand, Singapore, and Vietnam. And I also actually see some familiar names here. Well, another thing I would like to mention here is that we were kindly supported by the IAEA, or International Atomic Energy Agency. And we also have a representative from IAEA here with us today. Tamara is with us today. So with that support from the IAEA, we also got the calculation results from the UK. So here you see the name of Dr. Tom Charnock, and he was the one who provided the results from the UK with our benchmark problem exercise. So next slide, please. I would like to touch a little bit about the motivation that why do we need to perform this kind of accidental release simulation in ASEAN, even if we don't have, well, even one nuclear power plant in the region. Well, it is because, well, actually several ASEAN member states have expressed interest in nuclear power from time to time, but unfortunately have never proceeded to operation. But I think, as all of you may know, the risk of a nuclear accident is actually very evident. It was demonstrated by the 3 accidents in the past, whether in 3 Mile Island in 1986, in 1979, or in Chernobyl in 1986, and lately in Fukushima in 2011. And this led to public anxiety and consequently the opposition to nuclear power. And that's one of the main reasons that several ASEAN member states decided to try to proceed for this nuclear power program, but never ever succeeded. And another really important thing is that the dispersion of radioactive materials has no boundary, so it can go anywhere. So even if the power plant is, for example, in Japan, you also see some extent of radionuclides in, for example, in South Korea, and also it even go onto the other side of the world to America. And another important thing is that radiation itself is not visible, so you will not know exactly where it is at the moment. So that's the reason that even there is no nuclear power plant in ASEAN, we need to know how to manage the accident to be able to respond very well to these kind of events, in case it happens. So come back to the technical part, then there are quite a number of atmospheric dispersion models available anywhere, in many places in the country. So there are a number of calculation codes. Some of them are free of charge, so you can just access to it very easily. So some of them you need to pay some amount of money to be able to use it, and they have more sophisticated models, and sometimes they are more user-friendly. So when the tools are available there, so it's our duty to make ourselves capable to use them. And that's the reason that in ASEAN, we decided to do this benchmark exercise to make use of the resources we have. So make use of the calculation codes and the dispersion models that we have, and then do some calculations with, I would say the same conditions, and then try to see that what are the differences, and also what would be the cautions that we need to have, and what are the things that we need to be careful when we perform this kind of calculations. Next slide, please. So the objective of this study is to compare the results of this kind of calculations. So it's a calculation of atmospheric dispersion of a radioactive release from a hypothetical accident. So it doesn't mean that the accident has already happened in that particular nuclear power plant, because it's hypothetical. So we believe that, if it is going to happen, hopefully it doesn't happen. So if it's going to happen, it will be this way, for example. And in an external nuclear power plant, because we have no nuclear power plant inside our region. And this is performed by different calculation codes, and also employing different model. So there are two models that we particularly employed. There are Lagrangian particle model and Gaussian path model. So these are two main models that are being used in most calculation codes at the moment. The Lagrangian particle model is a little more sophisticated, and it consumes a little more resources, while the Gaussian path model is a little simple, but the result is not very accurate. So we hoped at that time that the insights produced by this study will be able to be used as a decision support aid for an appropriate risk-informed response of countries in ASEAN, and also to derive precautions when we use different types of calculation codes to calculate the similar situation in case the accident happens. Next slide, please. So this is the framework and the methodology of the calculation. So we started with the review of the calculation codes and also the dispersion models. So actually so several countries have more than one calculation code. So we review the calculation codes that we have and see that what are the dispersion models that the codes employ, and then try to see that which would be the most appropriate one. Well, actually, for Thailand, we performed two different calculations with two different modules in the code, and then we select the location, and then we determine the calculation condition. So when we say calculation condition determination, it's actually seems to be like very simple step, but actually we needed, I think, more than a year to define good conditions, because actually we need to have the condition that we are able to see the impact to the region, not to any particular country. And then after that, we did the calculation, and then we compared the results. So on the right-hand side, so I listed the codes and models being used. So there are FlexPart and the LASAT model of GeroDOS, and also name3, a model of PACE. Three of them use the Lagrangian particle model. And then there also Argos and GeroDOS rim puff module, which employ the Gaussian puff model. And for the calculation conditions, the source would be a nuclear power plant in China located, well, 50 kilometers from Vietnam border. I refrain from using the word, the exact word of the power plant, because actually that can be problematic in some cases. And then the accident we used was long-term station blackout. And then the radionuclides we used were iodine 131 and cesium 137. We use iodine 131 because it represents the short-term consequences, and the cesium represent the long-term consequences because it has long half-life of about 30 years. And we use two different methodological data. Again, we discussed a lot before we came up with this two scenario. We thought that, well, we need to do two different calculation. Well, first one is the dry scenario and the other one is the wet scenario. Next slide, please. Oops, it's like the slide is not moving. Okay, so actually from this slide, there will be like series of the results. So you will see a lot of figures from now on. So I would like to spend a little more time on the first slide because after that you will see very similar things. So this is the result of the integrated air concentration of the calculation of the dry scenario. And this is only for the iodine 131. So you would see that actually when we talk about the atmospheric dispersion, first we will start with the fact that, well, when the radioactive particle is released, so it can go everywhere, it disperses in the air. So we would like to know that, so what would be the concentration of the radio particles in the air? So this is the result that we receive. So the top left is calculation results from FlexPart, and the middle is GeroDOS, the LASAT model. The top right is result from PACE. The bottom left is result from Argos, and the bottom right is result from the rim puff model of GeroDOS. So you would see here that actually the result is very similar in terms of the direction of the dispersion. So actually the radioactive particle started going to the southwest first, and then it moved to northwest first, and then it moved to southwest later. And this was captured in most of the calculation codes. However, you would see that there are some differences in dispersion distances here. Next slide, please. So the next slide is actually the integrated air concentration of cesium 137. So you would see that it's very similar, but the only differences we can see here is that, well, it's a little bluish when you compare with the iodine 131. It is because we are considering only 24-hour duration. So basically what we can observe would be the short-term consequences, and we have less long-term consequences. And so we have the bluish color for the lower concentration. So the concentration of cesium 137 is actually basically lower than iodine 131. Next slide, please. So after we see how it disperses in the air, then so we see that how it deposits on the ground, and then we capture the concentration of these particles on the ground. So you would see that it still basically go on to the northwest direction and southwest direction. But if you see the top three and also the bottom left, you would observe some, well, I would say micro scale dispersion. Especially this is very notable here on the top left figure, that, well, apart from the two main directions, there are also dispersion to northeast on the top. of the figure. So this can only be captured by the calculation codes that employ the Lagrangian particle model. Next slide, please. Next is the ground concentration of cesium-137. So very similar to the air concentration. So for cesium-137, you get much less concentration comparing to iodine-131. Next slide, please. Then we move to 1-day TEDE. This TEDE stands for total effective dose equivalent. So it's basically the radiation that people are supposed to be receiving. But again, well, this is with the condition that all those people need to stand still there outside without any buildings. So they should stand there for 24 hours and they will be receiving this this amount of radioactive dose. So you would see here from this slide again that in the Lagrangian particle model, you would see some microscale dispersion, but you cannot observe that on the two bottom figure that employ the Gaussian path model. Next slide, please. So I summarize a little bit the findings from the qualitative comparison. So when we compare the figures here, we see the shifting of wind direction from north or northwestern direction to southwest. And only Lagrangian particle model can capture the microscale changes in wind direction. And finally, there are slight differences in plume traveling distances. And though this actually could also be attributed to difference in meteorological data set. Well, actually, at first, we agreed upon we agreed that we will use the same meteorological data set, but then we found that actually to transfer the data, the meteorological data, well, it's quite difficult. So finally, each country employ its own meteorological data set that they got from their meteorological office. So we are using different meteorological data set, and that can also be one of the reasons of the differences in traveling distance. Next slide, please. And we actually also did the quantitative comparison, and we have the table that compare the quantitative results from all calculation codes, but I didn't put it here because well, there will be a lot of figures, and I don't think that you would like to see it. I mean, a lot of numbers. So for integrated air concentration, there are slight difference among calculated values, but significant variation in directions. So the difference in calculated values are not very large, but there are significant variation in directions of maximum concentration. Because as I said that, well, there are microscale dispersion that cannot be captured by the Gaussian path model. So there are some differences in direction. Next, for the ground concentration, we found similarity between flex part and pace, but they are quite different from zero DOS, whether LASET or rim path model, and also different from Argos. Regarding the 1-day TEDE, the zero DOS employs the most conservative model, and that's actually the reason that the ASEAN NPSR is now moving toward this dose assessment, because we believe that actually different calculation codes are employing different dose assessment models. So regarding the exposure extent, so first the definition of this exposure extent is that the distance is the distance from the release point until the point that of 1 microsievert TEDE, and it's 273 to 397 kilometers. And the lead time is actually the time that the plume reaches the boundary of one of the ASEAN countries, and it's approximately 13 hours that it reached Vietnam for this dry scenario. Next slide, please. So next is the integrated air concentration of iodine 131 for the wet scenario. So we also made the calculation of the wet scenario, and this wet season is actually during the northeast monsoon period. So I think it starts in November and ends in like February or March. And actually during this period, it's pretty dry. So we try to find the days that are wet, well, the day that we can observe some rain. And actually another important fact during this northeastern monsoon period is that there are constant wind to the southwest direction. So that's the reason that we thought that, well, that's one of the most probable time that we could observe the radioactive materials being dispersed from China. So you can see here from the integrated air concentration of iodine 131 that actually it dispersed quite far within 24-hour time frame. So it even extend until Thailand. Next slide, please. So as I said that, well, the maps will look really similar between iodine and cesium. So I omitted the cesium 137 and then go to the ground concentration of iodine 131. Again, you can see, especially from the top three figures, that if you look at the models, the calculation codes that use the Lagrangian particle model, you will see that there are a lot of micro scale dispersion that can be captured within the model. Next slide, please. So when we move to see the one day TEDE, so even if we found slight differences, whether in the dispersion pattern or in the dispersion distance, but we can see that basically the direction are to the southwest. Next slide, please. So so I would like to summarize again the findings from the wet scenario, that the wind direction is basically southeast to the southeast. No, sorry, southwest. Sorry, and only Lagrangian particle model that can capture microscale changes in wind direction, and it's the same as the dry scenario. And then strong wind during the northeast monsoon can bring radioactive materials, contributing to integrated radiation dose over 1 microsievert to several countries in ASEAN, namely Vietnam, Laos, and Thailand. And then extreme weather or existence of rainfall does not significantly affect the difference in prediction capability of the calculation codes. So whether it's the dry scenario or wet scenario, basically the prediction capability is very similar. So Lagrangian particle model will result in more accurate results, and then you can capture basically the direction only from you can only capture the direction from the Gaussian Plough model. Next slide, please. Again, so actually this slide is very, very important. So when we do the quantitative comparison of the wet scenario, we would see that well, the integrated air concentration or ground concentration or TEDE are very similar to dry scenario. The exposure extent is much longer, 600 to 900 kilometers, and the lead time, well, is around 11 to 13 hours to Vietnam again, and also like around 20 hours to Thailand and Laos. So you see here that the fact that the radioactive plume can possibly reach ASEAN within 24 hours seems very alarming. But I would like to point out two very important facts here. The first one is that, well, the exposure to radiation at the dose of 0.1 microsievert per hour. I'm talking about 0.1 microsievert per hour. Well, so micro is like 1 by 1,000 of milli, right? So it's actually very small. So in 1 year, even if you receive constantly this 0.1 microsievert per hour, it will only give the annual dose of 0.9 millisievert per year, which is still smaller than the reference level for normal exposure. So when they say normal exposure, it's actually the reference level that they are using for the natural exposure, the exposure to natural radiation. So like the radiation that we can find in the normal environment. And the basic reference level for emergency exposure is actually 20 to 100 millisievert per year. So you would see that the radiation that we are discussing here in this dispersion is extremely small when we compare to the exposure in the emergency situation. So here, the typical emergency response, for example, evacuation of people or like asking people to shelter in the building are not applicable. So if this prediction is appropriately combined with the information from the radiation monitoring system on, well, like if they monitor some abnormal spikes and then they compare with the dispersion calculation, this will keep the responsible authorities informed of the situation once the accident happened. Next slide, please. So final remarks here is that for the purpose of designing appropriate response to a radioactive release from an external nuclear power plant, well, calculation codes employing Gaussian path model would be appropriate to promptly provide initial information. So even if it's not so accurate, but it can capture the main direction of the dispersion. So we can use it to inform the radiation monitoring station so that they can be aware of the possibility of detecting artificial radionuclides, or they can also define the way to communicate the radiation risk to the public without triggering unnecessary concerns. On the other hand, calculation codes employing Lagrangian particle model can be used to perform a more accurate calculation afterward to confirm the results from the Gaussian path model. Next slide, please. Then, so we also took some steps forward from this calculation. So this is the particular part that we took in Thailand. So we thought that actually now we have quite a lot of information that once the nuclear accident happened, so what would be the consequences? So we considered a change over time of this accident consequences to be able to support the optimization of long-term remediation strategy. So we would see that how we can just come back to the normal situation after the accident, because I think that's the main concern of the people, and that's the reason that people are opposing the nuclear power. Next slide, please. And we introduced this concept of energy resilience, and that's the reason that I moved from this nuclear accident consequence assessment to assessing this energy resilience, because I thought that actually to be able to cope with all these accidents or the disruptions of any kinds of energy systems, you need this concept of energy resilience to be able to prepare to absorb any disruptions and also recover after the disruption, and finally learn from those disruptions and be able to adapt to any future situations in the future. So I think this ends my presentation. Next slide, please. I think I have my last slide to thank all of you, and then feel free to drop us an email if you would like to have any clarification. Thank you very much.
Yeah, thank you very much, Dr. Kampanart and Mr. Wasin, for the excellent presentation. It is interesting to note that actually when the accident happened, in fact, it will not affect much. I mean, to the closest one, for example, like Vietnam, Laos, PDR, and Thailand. And you noted that the radiation level is quite low, and also the dispersion itself will reach the neighboring country like in 24 hours, which gives us time to evacuate and etc. etc. So my follow-up question from that actually, because it's like foreign things for me actually. First is how far should people evacuate if that's happened? Like how far from the accident? That's the first question. And then the second question is, does the ASEAN nuclear safety network also consider a topic where, for example, in ASEAN, we have, for example, maybe like Philippines would like to build the nuclear power plant, whether the member states discussing to have some kind of agreement if member states build the power plant, there should be a certain radius from the neighboring country, so it would be safe if the accident happened. Yeah,
So,
maybe those two questions to start.
Okay.
Thank you.
So I will start with the first one first, and then the second one, maybe I'll partially answer the question and then pass it to Wasin later. So with the first one, so before actually answering the question, I would like to also make one remark that actually this is based on the calculation of only 2 case studies. So there are also some cases that some part of Vietnam that is very close to China may get some effects that people may need to shelter. So that's one important remark that I would like to have. Can you repeat the first question again?
Yeah, like how far maybe the people that closest to the I mean, like for Vietnam, like the one in the border should evacuate from his place when the accident happened.
Okay, so I will talk from 2 points of view, and the first one, the very general point of view. So based on calculation of several countries around the world, up until now, I mean, before the Fukushima accident, it was said that, well, the basic distance for evacuation will be somewhere around like 5 to 10 kilometers, and the basic distance for sheltering will be around like 10 to 30 kilometers. But after Fukushima accident, that was extended to a little longer. The evacuation distance can even go up to around like 30 kilometers. So it depends on the meteorological conditions. And also the distance for sheltering can extend up to 80 kilometers. But that's for the countries that own the nuclear power plant. So for countries like us, for example, like for Thailand, which we have no nuclear power plant in several hundred kilometers boundary. So for Thailand, I don't think either evacuation or sheltering are important. I mean, are necessary for us to do. But for some parts of Vietnam, I think we may need to think a little bit about sheltering people inside some places in case very serious accident happen in this particular nuclear power plant. And the second point, well, I will just touch a little bit on the ASEAN NPSR. So actually, there is another entity called ASEAN TOM in ASEAN. So I think if we talk about the regulation, it would actually go to that particular entity. So ASEAN NPSR will look after more the scientific part of these things. For example, if the ASEAN TOM need some information for them to make decision that what would be the agreement that they need to make, then if that's the situation, then I think the ASEAN NPSR will come into the roles. So Wasin, do you have anything to add?
Yeah, I have some updates about how far that the accident happened, and as the Kampanart say, dependent on the based on the Fukushima accident, and now there are many nuclear reactors in the new types, such as small modular reactor or the innovative reactor that use another field. And there are many studies that discuss about the exclusion zone or evacuation zone after the update of the new model types. After I discussed with my colleague yesterday about the small modular reactor, we found that the exclusion zones of the small modular reactor suggest around 5 kilometers for the concern about the accident happen, and the accident is have the impact less than the nuclear power plant in the past. That is the last nuclear power plant, and we can compromise some the regulation or create some requirement to build a new type of nuclear power plant. This is because it is have the potential to have the less consequences than the Fukushima accident. Just only additional information.
Thank you very much, Mr. Wasin and also Dr. Kampanart. It's well noted that the policy discussion is more on the ASEAN TOM and whether it is about the research and then explorative ideas. I would say it's more into the ASEAN nuclear power safety network. So another follow-up question, because I noticed we have a few questions here. Maybe I would like to raise the question from Tamara. What are your plans going forward for the study and also the network itself?
So I think, Wasin, would you like to answer that question? Because it's the way forward of NPSR.
Okay, thank you, Tamala, for your question. And as for the next step of our ASEAN, and I would like to update the detail that I discussed in the last annual meeting with our ASEAN member state. At that time, we try to enlarge our ASEAN NPSR network to study more than the atmospheric dispersion assessment in the first project, and we still continue the first project and last to the dose assessment that I mentioned in the slide before. And another one thing that we concern in our ASEAN, this is the nuclear safety of the research reactor. This is the research reactor is the only one fission reaction nuclear facility in our region, and we have the research reactor Thailand and Vietnam, the Philippines or Indonesia. Yeah, too much research reactor here, and this is another concern that we would like to go to conduct the research. And the main research that I talked to at that day is the probabilistic risk assessment, and I think it is possible because we can acquire and contain the data which is such about the failure rate analysis data or the survey data in order to collect the data record like document that the EA works in the past about the research reactor around the world. And I think it is an important part that if we can have the ASEAN research reactor data about the risk assessment, which is author. And another one that I talked with our colleagues is the nuclear renewable hybrid energy system. And this is the new trend that many countries around the world concern. And at Thailand, we talk to this point too much. And the first thing that we can do, this is the study about the feasibility or the possibility of the renewable hybrid energy system, or focusing on the impact assessment if we have them in the future. Yeah, this is the first step that we talked to in the past, and I hope it is the next step of our NPSR too.
Yeah, just just to cover the latter part of the comments that was given by Tamara. Well, thank you very much again for being here, because I think it's quite early there in Vienna at the moment. So I think on this nuclear renewable hybrid energy system, there is actually quite a lot of possibility on this topic, and I think this is also being discussed in the IAEA. Especially in the in-pro section. So I think the nuclear can address the shortcomings of renewable energy in terms of stable energy production. And on the other hand, the renewable energy also can address one important shortcoming of nuclear, which is the public acceptance. So I think it may not go to the step of considering the safety of this system yet, but I think we can start considering the feasibility of this kind of system, especially when we know that this for the hybrid system, basically they are using the small modular reactor or a very small scale nuclear power plant. So in that sense, it will be when it's very small, then for example, the evacuation zone will be like 1 or 2 kilometers, or sometimes only the boundary of the power plant, the power plant site itself. So in that case, the public acceptance may be better. And also on the other hand, it also can help address the stability part and the stability issue of renewable energy. So on that specific topic, we are now discussing with TINT, Thailand Institute of Nuclear Technology, whether we can have a collaborative project or not.
Yeah, thank you very much, Dr. Kampanart and Mr. Wasin. Indeed, I personally also agree with what Dr. Kampanart remarks, that nuclear is actually quite important to support the renewable energy development, because it's like the only viable source sustainable source that can act as the base load, right? So I think it is also important that speaking from the A side, from we think that because under under the energy cooperation here, we also have one program area which is about nuclear, and we think it is also important that in future we could like collaborate more on spreading the awareness on how safe actually nuclear is, basically to know the animal here, because it's not as dangerous as it is. In fact, it is quite useful and it's safe. So yeah, well noted, and agree with Dr. Kampanart that in fact nuclear supporting the energy resilience concept for the renewable development. So I noticed that we have one participant that raised hand. Mr. Rizky, may I ask you to open your camera and unmute yourself to share your question or opinion directly?
Yeah, thank you, Monica. Hi, Dr. Kampanart and also Mr. Wasin. It is indeed it's quite strange for me for the topics, but the way you deliver it is very great. So I noted some key points, especially when we when one nuclear power plant has an accident, and then we can mitigate from your analysis. We can mitigate. This is the flow of the concentrations of the radiation, and then this is the area that still that needs to be evacuated, maybe. So we can analyze, and then we can mitigate the impact like that using this analysis. But I would like to ask more technical questions. Maybe you already explained it, but I still for me it's still unclear for me for what kind of parameter that you use to decide which codes or which model that you will use to calculate the dispersions, because in your last slide, if I'm not mistaken, the Lagrangian is more detailed, where the Gaussian is more general, if I'm not mistaken. Correct me if I'm wrong, but basically my question is, what is the main parameter or the main consideration when we, okay, let's decide to use this Lagrangian, or for this time we can use Gaussian only for it, because you're comparing both of the calculation methods. I think that's my question. Thank you, Monica.
Yeah, please, Dr.
Okay.
Kampanart.
Okay, thank you very much, Mr. Rizky, and thank you very much for asking this technical question, because I think that's the most important part of the paper itself. Wasin, can you go to the remarks slide? I think it's like slide number 25. Yes, if I remember correctly. Yeah, so I think it's it's here. So basically, when we consider that what kind of models we are going to use, I think there are 2 or 3 important things that we need to concern. The first one and the most important thing is actually the accuracy. So we will try our best to use the most accurate calculation codes. I mean, most accurate model and most accurate calculation codes. And after the comparison of these two models, so we found that the Lagrangian particle model is more accurate than the Gaussian puff model. So that's the first thing. The second thing, we need to think about the calculation resource. So, so if you would like to have the results promptly, so like you can spend only, for example, 5 minutes or 10 minutes for the calculation, and you need the results right then. So you need to take, well, very little resource, right? Otherwise, you will not be able to make the decision promptly. So during, well, once the accident happened, so actually you need to start using Gaussian puff model, which consume much less resource first, to actually first capture the direction. And then you can move to the Lagrangian particle model later, when you have more time to get a more detailed results. And well, actually, I have another thing, the third one, which is actually also equally important, and it's related to the precaution that we need to have when we perform this kind of calculation, is the sophistication of the calculation code. So basically, the Gaussian puff model is very sophisticated and it's very complicated. So you need to make sure that the analyst or the one who used the calculation code knows well about the model. Otherwise, it will be so like the, well, garbage in, garbage out, right? So if you cannot use the good input, I mean the exact and good input, then you will not get the good results. So if you are not capable of using the Lagrangian particle model, which is more complicated, I would say that it would be better for you to stay with the Gaussian puff model, which is more simple.
Yeah, Mr. Wasin, do you have anything to add? No. Oh, okay.
No, please.
Yeah, okay. So thank you very much, Dr. Kampanart, for the explanation. And hopefully, Mr. Rizky, may I check if you are happy with the question, the answer, or do you have any follow-up question?
No, I think it's quite understandable from my side.
Yeah,
I think
thank you.
this kind of analysis is quite important, since ASEAN is also, yeah, we have already the program areas on civil nuclear energy, and I think once we later decide to have a nuclear power plants in ASEAN, and then it will be crucial. I mean, really crucial for ASEAN. So, thank you, Monica.
Yeah, thank you, Mr. Rizky. So now we are actually, the time is already reaching the end, and maybe we need to extend for another 5 minutes. Is it okay, Dr. Kampanart and Mr. Wasin? Yeah.
I'm fine with that.
Yeah.
So yeah, and Tamara, yeah, thank you. So yeah, thank you for having you here, and yeah, look forward to see you again, Tamara. Anyway, so as the final question, and maybe later you can share your final remark before I move on to the last session to introduce our activities, our future activities. I would like to ask one important question from Yuan Kyung-chu on does this benchmark would allow countries to pinpoint a suitable location for building a nuclear power plant in manner of a planning phase, or would it be difficult to gather the core inventory details of the potential location of the nuclear power plant? Yeah.
So I'll go first. I think it's the other way around. You will need to select the site first. I mean, if you think about the nuclear power plant, I think there are several aspects here. It's not only the safety. For example, you need to find like the stable ground. You need to find a place that can be connected to the grid, because it will be producing quite a lot of electricity, right? And also you need to find the place that are near like the cooling, well, I could say cooling sources like sea or very big river. And also you need to find a place that people are accepting this kind of facility. So there are really various things that you need to think during the site selection. So I think this safety is only one aspect that we need to consider. So I think you will need to come with the candidates first and then perform this kind of calculation rather than perform this calculation to select the site. So I think it's kind of the other way around. And regarding the core inventory, I think the exact data of the core inventory would be very difficult. But at the planning phase, the very, very initial phase, I think you can use some of very, well, I would say general data of the core inventory. So I think there are published data from NUREC. I think it's the data of the United States National Regulatory Commission. You can find this kind of very general core inventory data for the very initial calculation. And then after you found, well, the vendors that will be selling the nuclear power plants to you, you can directly get the core inventory data from them. I mean, the candidates of the vendors. So it's no need for you to select before you get the data from them. You can actually request the data from them during the selection phase.
Yeah, thank you, Dr. Kampanart. It's really informative actually for me. So yeah, thank you very much for that. Mr. Wasin, do you have any final comments, or do you want to respond to?
Yeah, as Kampanart say about the suitable location, and in the previous benchmark problem that we have, we choose the nearest nuclear power plant in ASEAN country, and the country that was suggested at that study is China and India that have the nuclear power plant, and they still are constructing the new nuclear power plant too, and the pressurized water reactor type is the one type that is constructing. And as Kampanart say, we can use the general information of the PWR type. This is the pressurized water reactor of PWR. Yeah, in order to assess in our study. And as for the another one point, if you can, if you have some some researcher from the country that you want to study, I think it is a good point. If you want more information from them in order to improve our research. Thank you.
Thank you very much, Dr. Kampanart and Mr. Wasin. As we know, already extended for another 5 minutes, and I need to ask more because I have to introduce our future events for another couple minutes. So allow me to end our discussion here and start sharing my few last presentations. Okay, so first I would like to introduce again about the ARNECC itself. So ARNECC is a group of scholars, analysts, researchers, students, and other stakeholders organized under the name under the themes of energy and climate studies. The main objective is to facilitate the interdisciplinary discussion like this of social, economic, governance, and technical issues related to energy and climate change. It is open to researchers from any discipline or level of experience and not limited to any particular technology or topic or sector from Southeast Asia. To register, please check the ARNECC webpage here. And if you have further questions, please let us know by emailing to benisuryadi@aseanenergy.org. Next, I would like to introduce you again to the ARNECC research database. This is the database that was established on July this year to be a platform for the member of ARNECC that want their publication on energy or climate topic to be disseminated more effectively to the Southeast Asian leaders. Please note that this database take the copyright terms seriously, so you may later check that the website only take the original DOI. And so far, we have received positive feedbacks, and by now we have updated the database, reaching 173 curated papers. We hope that the number keeps growing, so we are inviting the researchers who want to showcase their paper to simply submit details of your publication at the link here. Next is about the ARNECC Paper Talks. So now we have reached the 10th series, episodes, and we would like to maintain it to keep it going monthly every last week of the month. Here I'm also inviting our researchers who want their paper to be showcased to ASEAN audience from government, academic institution, and private sectors to please send detail of your paper, short bio, and photo to accept.com at aseanenergy.org. And then the last, I would like to share the ASEAN Energy Outlook Forum 2022 is the new event that we will introduce in the January of 2022, basically to showcase the regional energy outlook and to present and discuss the potential trends ahead that will impact the energy landscape in the ASEAN. And for the first edition, under the theme of Between COP26 and the RCEP, RCEP is the latest free trade agreement that will be effective starting early next year. ASEAN energy transition amidst the recovery. We'll present the insights from 2021 and examine the potential dynamics in 2022 and what will shape the energy development in regional and national level. Here we also highlight another findings from the survey that we have started since now. So to access, please go to the link given here for the English version, and you later could check in the Accept website that the survey also available in other ASEAN countries local language like Bahasa and also Filipino, Thai, and also Laotian and Vietnamese. So and also Chinese. So please feel free to share the survey and the link to the event itself to your network. And we have reached to the end of the presentation. Again, thank you very much for our distinguished experts here, Dr. Kampanart and also Mr. Wasin, for the insights and your valuable time for this event. I would like to also sincerely appreciate the active participation from the audience here, and also like the notable guests like Tamara, and I noticed also Professor Anhar that the former head of Nuclear Agency of Indonesia. I would like to say, please stay safe and healthy, and look forward to see you again in the next month, next year, ARNECC Paper Talks. Thank you. Thank
you. Goodbye.
Thank you.
you.
Goodbye.
Bye. Thank you. See you again.